This is another type of problems in continuity. See, find all points of discontinuity of f. So see the first one, let me show you how to solve these. What you have, f of x plus 1 when x is greater than or equal to 1, x square plus 1 when x is less than 1, correct? So find all the points of discontinuity. So first we'll see whether it is continuous at x is equal to 1 or not. All right. Here we'll start with LHL. So LHL, now we'll check LHL, RHL, and of course the limit at the particular point. So LHL becomes limit as x tending to 1 minus f of x. And RHL is what limit as x tending to 1 plus f of x, right? So now this one is going to become LHL is x square plus 1 because x is less than 1. So you have limit as x tending to 1 minus x square plus 1. RHL is going to become limit as x tending to 1 plus x plus 1. Make sense? Now put x value as 1 and this is going to give me 1 plus 1 which is nothing but 2. Here also 1 plus 1 which is nothing but 2. So what do we have? We have LHL is equal to RHL. See, since LHL is equal to RHL, and also if you look at it, this is also equal to f of 1, that is the limit at the particular point. Now, everywhere we are going to get that it is continuous. That means for the very first question, we can say there is no point of discontinuity. Or you can also say that it is continuous everywhere. All right, this is the answer for the first question. Now let's solve the second one. For the second one, again you have three functions. Here you have two things. We have minus 3 as well as 3, right? So we need to solve it according to what we used to solve in the previous two videos. All right. So first what do? We take f of x mod of x plus 3 when x is less than or equal to minus 3 minus 2x when minus 3 is less than x. I'm splitting it, okay? I'm splitting it into two parts. So in the first part right now, in this minus 3 case, we'll do LHL and RHL. So LHL is going to give my limit as x tending to minus 3 minus, and RHL will be limit as x tending to minus 3 plus f of x, right? This is nothing but limit as x tending to minus 3 minus mod of x plus 3. And here this will be limit x tending to minus 3 plus minus 2x, correct? Apply the value of x as negative 3. If you take it, mod of minus 3 plus 3 minus 2 times minus 3. So 3 plus 3 is 6. This is also 6. Both are equal. Correct, both of them are equal. And also if you look at the limit, that is LHL is equal to RHL, which is also equal to f of minus 3. This is also equal. Since both of them, all three of them are equal, we can say that it is continuous at x is equal to minus 3. But we don't know whether it's continuous at 3 or not, isn't it? Now we need to look at the second part. That is, what if x value is 3? Is it going to be continuous or not? Let's look at it. For the second part, see now what do we have? F of x is nothing but minus 2x when x is less than 3, 6x plus 2 when x is greater than or equal to 3. Alright, again left hand limit as x tending to 3 minus This is minus 2x. Guys, I'm directly applying the function itself, okay? Because you know that f of x is minus 2x, isn't it? This is equal to, and RHL is limit as x tending to 3 plus 6x plus 2, isn't it? Now what do we get? You apply the functions. You apply the value. Minus 2 times 3, and here it is 6 times 3 plus 2. Minus 6, this is 20. Obviously, these are not equal. So what do we say? LHL is not equal to RHL, isn't it? So here, what do we say? That f of x is continuous everywhere except x is equal to 3, correct? So we can say that f of x is continuous everywhere except x is equal to 3. Because at x is equal to 3, we are not going to have the continuity part. So it is discontinuous. Understood? So this is how we solve the second one. Now let's do the next one. See the third one. See, for the third one, what we have, f of x is nothing but mod of x by x when x is not equal to 0 and 0 when x is equal to 0, correct? So here LHL, RHL, take both of them, and also f of 0. F of 0 is 0, we know that any. Now LHL, RHL, when you take limit as x tending to 0 minus f of x, limit as x tending to 0 plus f of x, correct? Now when we do the LHL part, you're going to get, see, when you have x value less than 0 for a modulus function, now the function is going to become minus x. You have learned this in the functions part, correct? And also you have learned this last year when you're talking about the range and domain of a particular function, right? So what we are going to get, limit x tending to 0 minus x by x, and RHL is going to become limit as x tending to 0 plus x divided by x. So left hand limit LHL becomes minus 1 and RHL becomes 1, isn't it? So LHL is minus 1, RHL is 1. They're not at all equal, and that is nowhere even close to the value of the function, isn't it? So what we can tell, that f of x is continuous. F of x is continuous everywhere except x is equal to 0, because at x is equal to 0 it becomes discontinuous. Understood? So this is the point of discontinuity for the third question. Let's do the fourth one and fifth one now. See, for the fourth one, if you look at it, guys, it's very similar to the third one, don't you think so? Instead of mod x by x, here you have x by mod x, that's all. So now what do we have? You have f of x, x by mod x. Here x is less than 0, it's given. Minus 1 when x is greater than or equal to 0, alright? So what do we do now? LHL, the left hand limit will be limit as x tending to 0 minus f of x, which is nothing but limit x tending to 0 minus x by minus x, correct? Because when x is less than 0, the modulus function is going to become minus. So x by minus x, which is nothing but minus 1. Alright, well and good. RHL. So for the RHL part now, limit as x tending to 0 plus f of x, right? Now the value is given as minus 1 itself, right? What is the value of the function at x is equal to 0? See, this one is equal to 0 is here, and it is minus 1. So what do we have? We have LHL is equal to RHL is equal to f of 0. All three are equal. So we can say that the function is continuous everywhere. Or you can say there is no point of discontinuity. Alright, so here we can say that function f of x is continuous everywhere. Or you might as well say that there is no point of discontinuity. Understood? So this is the answer for the fourth one. Let's do the fifth one. See the fifth one? Now what do you have? F of x cube minus 3 when x is less than or equal to 2. Then x square plus 1 when x is greater than 2. Well and good. So first LHL will do limit as x tending to 2 minus f of x. Right? This is equal to limit x tending to 2 minus x cube minus 3. Correct? Since we have x cube minus 3, this is going to become 8 minus 3, which is 5. So 5 is LHL. Then limit as x tending to 2 plus f of x. Limit as x tending to 2 plus, what is my function? X square plus 1, right? 4 plus 1, this is also equal to 5. Now value of the function, that is f of 2. So when you take equal to, see this equal to is here. So you'll still get 5 itself. So what did we get here? We got LHL is equal to RHL is equal to value of the function, isn't it? Since they are the same, you can say that f of x has no points of discontinuity. No points of discontinuity. Understood? So these are the different types of problems. Okay, now whatever the problem set you have seen in the last 2 videos and including this one 3 videos, this or these are the types of problems what you can expect in continuity.